All right, let's dive into one of the most incredible, most violent events in the entire universe. What happens when a star meets a black hole? This isn't just about destruction. It's a story about identity, about how billions of years of cosmic history can be wiped out in an instant, and it leads to a mystery that pushes our understanding of reality to its absolute limit. So, to really get a grip on how a star's identity is lost, we first have to ask a pretty fundamental question. What even is a star's identity in the first place? It sounds like a simple question, right? But the answer is anything but. It's a story that's written in light, gravity, and time. Think about it. A star's identity is literally everything about it. It's not just a ball of hot gas. It's the exact amount of mass it has, its temperature, the unique chemical fingerprint of all the elements it's creating deep in its core. It's the color and intensity of its light, its complex layers. All of this, taken together, is a living record of its entire history, a story that took billions of years to write. So in this cosmic drama, you can think of it as having two main characters. On one side, we've got our star, this incredibly complex, unique, vibrant object. And on the other side, we have its complete opposite, the ultimate emptiness, the void, the black hole.
And this is where the real conflict begins. Our star has, well, countless properties making it unique. But a black hole, it's shockingly, almost terrifyingly simple. Physicists have this idea called the no-hair theorem, which basically says that a stable black hole has no complex features, no hair. It can be described by just three numbers. That's it. Its mass, its charge, and how fast it's spinning. All that rich, complicated history of the star is about to slam into that radical simplicity.
So, what happens when these two meet? Well, the process of erasing an identity isn't neat and tidy. It is unbelievably violent and chaotic, and it starts long before any part of the star ever reaches that infamous point of no return. The whole thing kicks off with the black hole's insane gravity. The tidal forces are so extreme they start stretching the star into an egg shape. This leads to the process with the best name in all of astronomy, spaghettification. The star is literally ripped apart into a long, thin stream of plasma. This superheated material then gets whipped around the black hole, forming a glowing, swirling structure called an accretion disk. Sometimes, from this disk, you get these colossal jets of matter blasting out into space at nearly the speed of light. At this point, the star as a single object is already gone. It's been completely dismantled. Now, inside that accretion disk, things get even crazier. The star's material is heated to millions of degrees, becoming this chaotic soup of particles smashing into each other. In that inferno, any unique chemical signatures, any hints of the star's original structure, they're just gone, completely wiped out. The star has effectively been melted down into its most basic, anonymous parts. But the true, final act of erasure, the moment of absolute finality, happens when the shredded remains of that star finally reach the most famous and most feared boundary in the entire cosmos, the event horizon. You know, the event horizon isn't a physical surface you could touch. It's better to think of it as the universe's ultimate one-way street. It's the boundary where gravity becomes so crushingly strong that the speed you'd need to escape is faster than the speed of light. And since nothing can go faster than light, once you cross it, there is absolutely no coming back. Ever. And what's waiting on the other side? Well, according to our current understanding, every single path, every possible direction leads to one place. The center, the singularity. This is a point where density and gravity supposedly become infinite, and the rulebook of physics as we know it just stops working. It completely breaks down. Whatever shred of information was left of that star is crushed into that single unknowable point. So, it sounds like case closed, right? The star got too close, and it's gone forever. But this is where our story takes a wild turn and becomes one of the deepest, most baffling mysteries in all of science. It's like we've just watched the perfect cosmic crime get committed, but there's a problem. One of the fundamental laws of the universe says this crime is impossible. And here's the law that's being broken. One of the absolute cornerstones of quantum mechanics, the physics that governs the entire universe on the smallest scales, is that information can never, ever be truly destroyed. It can get scrambled, hidden, rearranged, you name it. But the universe, in principle, always keeps a record. And what we just saw looks a whole lot like a record being completely and utterly erased. Which brings us right to the heart of what's called the black hole information paradox. If that star's unique identity, all of its information can't be lost forever, then where did it go? The black hole only remembers three simple things: mass, charge, and spin. So what happened to everything else? What happened to the star's story?
Well, one of the most famous potential answers came from the legendary Stephen Hawking. He theorized that black holes aren't completely black. They actually leak or evaporate over unimaginable timescales by emitting something we now call Hawking radiation. The hope is that maybe, just maybe, the star's lost information is somehow encoded in that faint radiation, scrambled up in a way we could never hope to read. But even if that's true, from any practical standpoint, the star's identity as it was is gone for good.
And this really gets us to the most profound takeaway from this whole violent process. Whether the information is truly gone forever or just hidden in a way we can never recover, the result for us is the same. It tells us something fundamental about what a black hole really is.
To put it simply, black holes are the great equalizers of the universe. They are completely, totally, and utterly indifferent to the complexity and the history of whatever falls into them.
Let's just look at the final tally. The star's billions of years of history, gone. Its unique composition and internal structure, erased. The only thing the black hole cares about is how much mass and spin it can add to its collection. A tiny white dwarf, a spectacular supergiant star, a planet full of life, it just doesn't matter. They all end up as the same, simple entry on the black hole's ledger.
And that leaves us with a final, kind of unsettling question to think about. A star's entire identity, a story written in fire and light across the ages, can be so completely and effortlessly erased by the laws of physics. So, if a cosmic identity is that fragile, what does that mean for our own?